scientists have spotted an enormous alien iceball streaking straight towards the sun. The 3.7-mile-wide, 6 kilometers, comet, called 96P/Mach-1, is thought to have come from somewhere outside our solar system and is being monitored by the NASA European Space Agency, ESA, Solar and Heliospheric Observatory, SOHO, spacecraft as it zips toward our star inside the orbit of Mercury, leaving an icy trail in its wake. Hello and welcome to KYC News. Please don't forget to subscribe and hit the bell icon. Comet tails are primarily composed of gas, which trickles behind the frozen clumps of ice and gas as they are heated by the sun's radiation. In 2008, an analysis of the material shed by 150 comets found that 96P/Mach-1 contained less than 1.5% of the expected levels of the chemical cyanogen, while also being low in carbon, opens a new tab, leading astronomers to conclude that it could be an interloper from another solar system. Now, its plunge towards the sun might reveal even more of its secrets. 96P is a very atypical comet, both in composition and in behavior, so we never know exactly what we might see. Carl Battams opens a new tab, an astrophysicist at the Naval Research Lab in Washington, D.C., told spaceweather.com, opens a new tab. Hopefully we can get some beautiful science out of this and share it with everyone as soon as we can. David Mochholz first spotted the eponymous comet in 1986 using a homemade cardboard telescope. Most comets that fall towards the sun tend to be smaller than 32 feet, 10 meters, wide, and consequently get burned up as they approach our star. But the gigantic size of Mochholz 1, it is more than two-thirds the height of Mount Everest, appears to protect it from complete evaporation, and the SOHO has spotted the comet making 5 close passes around the sun since its discovery. The icy interloper's closest approach to the sun came on Tuesday, January 31st, when it was 3 times closer to our stars than Mercury. The comet may have found itself on its strange orbit after being ejected from its original solar system by the gravity of a giant planet. Then, after a considerable amount of time wandering the cosmos, an accidental rendezvous with Jupiter could have bent its trajectory to ensnare it around our sun. Other theories also suggest that the comet might not be alien, but may have formed in poorly understood regions of the solar system or had its cyanogen blasted off by repeat journeys around the sun. SOHO has spotted more than 3,000 comets since its December 1995 launch, although the spacecraft's primary mission is to observe the sun for violent eruptions called coronal mass ejections, or solar flares that can cause geomagnetic storms on Earth. The most powerful of these storms can disrupt our planet's magnetic field enough to send satellites tumbling to Earth, opens a new tab, and scientists have warned that extreme geomagnetic storms could even cripple the internet. In the distant past, people were both awed and alarmed by comets, perceiving them as long-haired stars that appeared in the sky unannounced and unpredictably. Chinese astronomers kept extensive records for centuries, including illustrations of characteristic types of comet tails, times of cometary appearances and disappearances, and celestial positions. These historic comet annals have proven to be a valuable resource for later astronomers. We now know that comets are leftovers from the dawn of our solar system around 4.6 billion years ago, and consist mostly of ice coated with dark organic material. They have been referred to as dirty snowballs. They may yield important clues about the formation of our solar system. Comets may have brought water and organic compounds, the building blocks of life, to the early Earth and other parts of the solar system. Where do comets come from? As theorized by astronomer Gerard Kuiper in 1951, a disk-like belt of icy bodies exists beyond Neptune, where a population of dark comets orbits the Sun in the realm of Pluto. These icy objects, occasionally pushed by gravity into orbits bringing them closer to the Sun, become the so-called short-period comets. Taking less than 200 years to orbit the Sun, in many cases their appearance is predictable because they have passed by before. Less predictable are long-period comets, many of which arrive from a region called the Oort cloud about 100,000 astronomical units, that is, about 100,000 times the distance between Earth and the Sun from the Sun. These Oort cloud comets can take as long as 30 million years to complete one trip around the Sun. Each comet has a tiny frozen part, called a nucleus, often no larger than a few kilometers across. The nucleus contains icy chunks, frozen gases with bits of embedded dust. A comet warms up as it nears the Sun and develops an atmosphere, or coma. The Sun's heat causes the comet's ices to change to gases, so the coma gets larger. The coma may extend hundreds of thousands of kilometers. The pressure of sunlight and high-speed solar particles, solar wind, can blow the coma dust and gas away from the Sun, sometimes forming a long, bright tail. Comets actually have two tails, a dust tail and an ion, gas, tail. Most comets travel a safe distance from the Sun. Comet Halley comes no closer than 89 million kilometers, 55 million miles. However, some comets, called sungrazers, crash straight into the Sun or get so close that they break up and evaporate. Exploration of comets. Scientists have long wanted to study comets in some detail, tantalized by the few 1986 images of Comet Halley's nucleus. NASA's Deep Space One spacecraft flew by Comet Borrelly in 2001 and photographed its nucleus, which is about 8 kilometers, 5 miles, long. NASA's Stardust mission successfully flew within 236 kilometers, 147 miles, of the nucleus of Comet Wild 2 in January 2004, collecting cometary particles and interstellar dust for a sample returned to Earth in 2006. The photographs taken during this close flyby of a comet nucleus show jets of dust and a rugged, textured surface. Analysis of the Stardust samples suggests that comets may be more complex than originally thought. Minerals formed near the Sun or other stars were found in the samples, suggesting that materials from the inner regions of the solar system travel to the outer regions where comets formed. Another NASA mission, Deep Impact, consisted of a flyby spacecraft and an impactor. In July 2005, the impactor was released into the path of the nucleus of Comet Tempel 1 in a planned collision, which vaporized the impactor and ejected massive amounts of fine, powdery material from beneath the comet's surface. En route to impact, the impactor camera imaged the comet in increasing detail. 2 cameras and a spectrometer on the flyby spacecraft recorded the dramatic excavation that helped determine the interior composition and structure of the nucleus. After their successful primary missions, the Deep Impact spacecraft and the Stardust spacecraft were still healthy and were retargeted for additional cometary flybys. Deep Impact's mission, Epoxy, Extrasolar Planet Observation and Deep Impact Extended Investigation, comprised 2 projects, the Deep Impact Extended Investigation, Dixie, which encountered Comet Hartley 2 in November 2010, and the Extrasolar Planet Observation and Characterization, EPIC, Investigation, which searched for Earth-sized planets around other stars en route to Hartley 2. NASA returned to Comet Tempel 1 in 2011, when the Stardust new exploration of Tempel 1, NEXT, mission observed changes in the nucleus since Deep Impact's 2005 encounter. How comets get their names. Comet naming can be complicated. Comets are generally named for their discoverer, either a person or a spacecraft. This International Astronomical Union guideline was developed only in the last century. For example, Comet Shoemaker-Levy 9 was so named because it was the 9th short periodic comet discovered by Eugene and Carolyn Shoemaker and David Levy. Since spacecraft are very effective at spotting comets, many comets have linear, SOHO, or Ys in their names. The gigantic size of Mach holes 1 appears to save it from complete evaporation when it reaches the Sun. Since its discovery, the SOHO has also spotted the comet, making 5 close passes around the Sun. On Tuesday, January 31st, the icy interloper will be the closest to the Sun. At this time, it will be 3 times closer to our star than Mercury.